Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at calculating n. By n, I mean the sample size required to achieve a given confidence interval width when we know the confidence level. So this here is the formula for the confidence interval. Remember, we're creating a range of values in which p, the true proportion, lies. So you start with your value p hat, your estimator there, and remember the upper limit in the confidence interval is z times the standard deviation, and the lower limit is the value of z times the standard deviation. So we learned that in a previous video. So if you get a confidence interval like this, remember p hat is always halfway between the lower and upper value, so in this case it would be 0.18. So because p hat's always halfway between, the distance between p hat and the larger value is always equal to half of the total width of the confidence interval. In this case, I'm going to call the width of the confidence interval w, so half the width is w on 2. So half of the width is equal to z times the standard deviation. Now, if I use a lot of algebra skills to make n the subject of this equation, I end up with this formula here. This tells us how to calculate n. So, to use this formula, we obviously need to know z, that comes from the confidence level. W is the width that we desire, but you also need to know p hat. Now, often when you're doing these calculations, you won't know what p hat is. So when we don't know p hat, we use p hat 0.5. Why is that? Because p hat equals 0.5 gives us the largest possible variance. It's like the worst case scenario. If we use 0.5 for p hat when we don't know what p hat is, this will give us the largest possible value for n, so we can be on the safe side. So let's look at using this formula in some examples. So I want to know the true proportion of Canberrans that have blue eyes, and I want to know how many people I must ask so that my 95% confidence interval has a width of 0.04. So here we're calculating n, the number of people that I must ask. So it's equal to 2z. Now remember, for 95% confidence intervals, the value of z is 1.96. You divide that by the interval width that you want, in this case 0.04 squared. Now, we need to times by p hat, the proportion of Canberrans that have blue eyes. Now, I don't know what that is, so as I said on the previous slide, when you don't know p hat, you assume it's 0.5, and that means 1 minus p hat will also be 0.5. That's the worst case scenario. When p hat equals 0.5, that's when the variance is the largest. So assuming p hat 0.5, I can just put this straight into my calculator. So putting that in the calculator, I get 2,401. So I would need to ask around 2,400 people the color of their eyes, so that if I make a 95% confidence interval for the proportion with blue eyes, the width of that interval will be 0.04. So let's look at this question here. So I want to know if the population of Canberra is really 50% male, 50% female. And I want to be accurate within 0.5%. So how many people must I ask if my confidence level for my interval is 0.995? So firstly, I'm going to calculate what value of z to use at this confidence interval. So if we don't know what that is, we use the inverse normal function on our calculator, and we should get this answer here. So this means in the standard normal distribution, 99.5% of scores lie between 2.807 standard deviations below the mean and 2.807 standard deviations above the mean. So my value for z is 2.807. Next, we need to make sure we know the value of w. So we want our interval to look like this. The distance from p hat to the lower limit, 0.5%, and to the upper limit, 0.5%. So we want the width to be 1% or 0.01. And 50% male, 50% female, again, we're going to use p hat equals 0.5. So using the formula on the previous slide, we have 2 times z divided by w squared. Then we need to times by p hat, and if p hat 0.5, 1 minus p hat is also 0.5. So putting that on our calculator, we get about 78792. So you need to ask about 79,000 people in Canberra, survey them as to whether they're male or female, so that if you created a 99.5% confidence interval for the true proportion of males, your interval width would be 0.01. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.